4. And we're going to do some composite functions. Are you wondering why we're skipping 1-3? It's terrible. We'll kind of come back to it, but it's not good. Composite functions. 1-3 is all about like without your calculator being able to graph stuff. We are going to do that, but at a different time. Right now we're using our calculator to find things. Okay, so we're going to have 4 parts, but they're pretty quick. We only have 20 minutes. First of all, we're going to do some arithmetic with our functions. So you can take 2 functions and you can add them together, subtract, multiply, divide. Okay. So let's go ahead. Let's do some arithmetic. Number 1. Let's stick with these functions. Let's say that we have function f of x is 2x minus 3, and g of x is x squared minus 1. And we're going to do some arithmetic. So we're going to add, subtract, multiply, divide. So letter A, let's go ahead, and it might be written like this, f plus g of x. And that might bother some of you because it looks a little weird. Like, what does that mean? How can I add the f and the g without the x, but it is with x? This just simply, it just means this is f of x plus g of x. Okay, it's just weird to write it like that. So all you're going to do is you're going to take your 2 functions, you're going to add them up. Okay, so we're going to take 2x minus 3, and we're going to add that to x squared minus 1. And if you have any like terms, you can combine them. So I would probably write this as x squared plus 2x minus 4. And that's it. And that's adding 2 functions together. Pretty basic, pretty easy. Now, subtracting is harder. And I get some of you on this one. When I put this on a test or quiz, f minus g of x, which is the same thing as taking function f of x and subtracting g of x. When I do this, I get some wrong answers. What do you think people forget to do on this one? Yes, distribute. I know. I saw you do it like that. All right, 2x minus 3 minus all of x squared minus 1. And you can put both of those in parentheses if you want to. We're taking function f and subtracting function g. And so you have to distribute the minus. Okay? So we get 2x minus 3 minus x squared and then plus 1. So don't forget to do that on your quiz. And so we'll get negative x squared plus 2x minus 2. And that would be it. Okay, so these are all going to be worth 1 point, super quick problems. Letter C, f times g of x. F times g of x, they might even put f times g in parentheses. This is just to take function f and multiply it times function g. Okay, so the last ones were addition and subtraction, but this one's multiplication, so we're going to need a FOIL. So we've got 2x minus 3, x squared minus 1. When did you learn how to FOIL? Is it like 6th grade? 7th grade maybe? It's a long time, huh? I know, right? Yeah. All right, 2x times x squared is 2x cubed. I've been teaching for 20 years. I wonder how many times I've foiled. All right, and then minus 2x minus 3x squared, and then plus 3. And you have no, like, terms. You can just leave your answer like that. If you don't feel comfortable not writing it in standard form, you can rearrange it. But I feel comfortable. Do you? I do? Actually, I don't, but I'm just telling myself that it's okay. All right, next one. The book writes it like this. F divide by g of x. That looks weird. Okay, it's just simply taking function f and dividing it by g, but you have to list the restrictions. And I would, if I were going to give you a division problem, I would say restrictions, like I would remind you, okay? So what that means is this. You have 2x plus, no, minus 3, sorry. 2x minus 3 over x squared minus 1. Now there's nothing to do here. I can't divide, I can't cancel stuff out, anything like that. But I do have to tell you that this works. I can divide f and g as long as x is not what? Or? Perfect. Okay? So you have to kind of tag that on. Like, it's okay to do this, but not when x is 1 or negative 1. You can't divide those two functions. Okay. All right, you feel pretty good? Am I insulting your intelligence? All right, letter B. Now let's do some compositions. Composition of functions, functions inside of functions. Kind of like that, remember that movie? Inception. Yes. I had to watch that a couple of times to finally understand it. All right, composition of functions looks like this. F of g of x. Do you remember those? Fog, yeah. Usually when I write that, people groan. Ooh. Yeah, like that. They do. Okay. Do not. I'm sure you have. Okay, f of g of x. That means that g of x goes inside of f. So let's go ahead and look at some of these. So number 2. Oopsie. My pen won't write today. I think it's all of like Andrew sneezed on my iPad over the weekend. No, the ink, yeah. All right, so let's just use those same functions from above, and let's do f of g of 8. Okay? Do you remember doing these last year? Yeah? But they were hard. Teaching this in Algebra 2 is a hard concept because it's the first time you see it. It's really kind of confusing. But you're going to start from the inside out. You're going to take 8 and plug it into function g first. So g of 8 is, what is it? 8 squared minus 1, which is 63. And that's not your answer, and it's not half of your answer. It's not part of your answer. It's going to get you to your answer. So then now you have to do f of 63. You plug in 63 times 2 minus 3 is, anybody want to do that math? 123? 123? Thank you. 1, 2, 3. It's as easy as 1, 2, 3. Thank you. All right.
Yeah, it's not funny. I was thinking about something else.
No, it was funny. You laughed. Number 3.
It's like when we went on the surf trip, Peter, I don't know. The Peter River. Yeah. It was.
All right, let's do this one now. It just reminded you. Okay, let's do f of g of x. So no numbers anymore. So now we're going to take, and I'm going to write my functions over here so that you see what I'm doing. So this is 2x minus 3, and g of x was x squared minus 1. So I'm going to take function g of x, the inner function, and I'm going to pick that up, and I'm going to take this x out and plug that entire thing in. Do you remember that? You're not multiplying them together. You're not leaving them both there. It's kind of like I'm the x right here, and I got to go to Disneyland, and then the sub comes in and subs for me. We're not both here. I leave, they come in. So that's 2 times x squared minus 1 minus 3. Okay, so then you get 2x squared minus 2 minus 3 gives me 2x squared minus 5. Hold on, I'm going to check something out real quick. So it's pretty cool because if you have this formula, then, and if you wanted to find out what f of g of 8 is, you could plug 8 into here, and it'll give you 123. Okay? So, but there are restrictions. So let me show you this next one, and then we'll move to the third part. So number 4. If I tell you that, I'm going to change f of x and g of x finally. If I tell you that f of x is the square root of x, and g of x is x minus 1. Okay? And then I ask you to find f of g of 0. F of g of 0. You can't, right? What's g of 0? Negative 1. So then I'd have to do f of negative 1, which is the square root of negative 1, and we're not doing imaginary numbers. And so you actually get no solution for this one. Okay? So that brings us to, well, what happens when you have numbers that you can't plug in, numbers that you can, what's it going to be? So that takes us to part C. So we're going to talk about domain. Now here's the thing about domain. It's not going to go away. We're going to do domain a lot, pretty much every chapter. Okay, so if you're struggling with domain, you're not sure how to find it yet, please let me know. Come in early. Not tomorrow, I have a meeting, but Thursday. All right, so let's go ahead and we're going to find the domain. So when we're looking at the domain of f of g of x, we need to do two things. We need to look at the domain of the entire thing, f of g of x, but then we also need to look at the domain of g of x to make sure that the numbers can get placed into g of x first and then into f of x. Okay? All right, so we're going to do two of these. We're on number 5. Okay, suppose that we have, this one's a little tricky, so be careful. Suppose we have f of x equals x squared minus 9. Okay, first of all, that's just a parabola. Anything you want can be plugged into there. And then we have g of x equals, and this is going to be weird, the square root of 9 minus x squared. Okay? If I was going to have you find the domain of that, I would let you use your calculator. So let's do two parts. Part A, let's find out what f of g of x is. Okay? You do that. Not sure where all those things came from, but because I paused it. Okay, anyways, so you're going to take g of x, and you're going to do 9 minus x squared, and you're going to square it and subtract 9. Okay, did you get negative x squared? Good. The square and the square root are gone, 9 minus 9. You end up with negative x squared. Now, negative x squared has a domain of all real numbers. Okay, but this is not all real numbers. You can't plug in anything you want. If I tell you to plug in 4, if I tell you to do f of g of 4, you would get 9 minus 16 inside of a square root. You can't have that, okay? There's no solution to this. So you have to go back and look at the function g of x. And I would like I said, I would let you graph that. That is the graph of the top half of a circle. And the domain of that is negative 3 to positive 3. Okay? And so what we would say is the domain for f of g of x would be negative 3 to positive 3. That's the domain. That would be your answer. Maybe it's this thing. Oh, yeah, it's ripped. Yeah. I was just showing you, like, if I did try to plug in 4, it's not going to work. Yeah, that was just an example, like a real quick example, to try to plug 4 into G, and then it doesn't work. So the domain's not all real numbers. It can't be. All right, let's try one more of those. This is the hardest part of today. The last thing is super fun and easy. Well, maybe not fun, but it's easy. All right, suppose we have f of x equals 1 over x, and g of x equals 1 over x plus 1. Okay, now, as you know, both of these have domains that are not all real numbers. What's the domain of f of x? This one? All real numbers except for 0, okay? And then this one? All real numbers except for negative 1. Now let's find the domain of f of g of x. So f of g of x would look like this. We're going to take g of x, which is a fraction, and we're going to plug it into a fraction. So we have 1 over x plus 1. You cannot leave anything with fractions over fractions. Do you remember how to fix this? Take the bottom and flip it around. And so we get that this is really times x plus 1 over 1. Okay, you can do that with division. Shh, focus.
I'm sorry.
All right, so then you get x plus 1. Okay, that's f of g of x. Now, f of g of x, this, if I came up with x plus 1, that would have a domain of all real numbers. I can plug anything I want into for x. But if you're going to do f of g of x, you have to look at the domain of g of x. So this would be all real numbers except for negative 1. Negative 1 is not going to work.
It doesn't. Sorry.
Okay? So don't just look at f of g of x, because people will do that. They'll find out what f of g of x is. They'll find the domain of this. They'll be like, oh, cool, it's all real numbers. But then if you try to evaluate this for f of g of negative 1, you're not allowed to. So it's not all real numbers.
Wait, so if they're all real numbers, that's can equal or
Can't. Whoopsie. Thanks. All reals except for negative 1. Because if you'll get 1 over 0. Yeah. Yeah.
Okay, so you have 1 over x plus 1.
Yes.
So can you explain that?
Yeah. So if you have 1 over x plus 1, the way that you do this is you take the bottom and you flip it and multiply. So like if you were to take 1/2 divided by 3/2 or something. Have you ever done that before? Mm-hmm. You take 1/2 and instead of dividing by 3/2, you multiply by its reciprocal. You flip it. That's how you learned how to do those back in the day. 1/3. No?
I remember someone teaching us that.
Yeah. Okay, now the last part is to identify. Identify the composite function. I only have a couple minutes left.
Hurry.
Shush. All right, so we have h of x.
That's an N.
H of x equals f of g of x. Okay. So our job is going to be to identify what f of x is and g of x is. So number 7. I'll show you by example. They tell us that h of x is equal to 5x plus 1 cubed. Okay? It's kind of like it's the end. Like we just put two functions together. What were those functions? What was f of x and what was g of x? Now, g of x is the inner function. So you have to look at this. H of x is kind of like two functions in a way. There's an inner function and there's an outer function. Do you see it? The inner function is this 5x plus 1. That's going to be g, 5x plus 1. And I take 5x plus 1 and I plug it into what to get 5x plus 1 cubed? X cubed. Exactly. It's working backwards. It's kind of weird, huh? And please, do not tell me that one of them is x, because one year, I put this on a quiz, and I had a student tell me that g of x was this entire thing, and f of x is x. So you just plug it in and you get it.
That makes perfect sense.
That's cheating.
It's not cheating.
It is right. You're right. It is right.
Did you mark them off?
I think I ended up putting on like the quiz, do not let one of them equal x or something, because I couldn't mark him wrong because he was right.
Dang. I'm going to write that up by next quiz.
Okay, good. Yeah. All right. H of x equals
Makes sense, yeah.
1 over x plus 1. All right. Try this one on your own. It's the last one of the day. Okay. Try this one. Find out what g of x is and f of x. It's a little trickier. But think of an inner function, like a function that you see, and then the whole big picture. I think you get it.
Price, how was your weekend?
Really great. Saw 5 hockey games.
5?
And Greg won the tournament. Well, his team did. G of x is going to be, what'd you get, x plus 1? And f of x is 1 over x. Perfect.